Audio Jungle. Audio Jungle.
All right, so now this is the problem. Last class also we had solved the problems. So now two more problems we need to solve here. Okay, and this is I think problem number 3. Last class we had solved two problems based on the turning flight. Now the question is an an airplane weighing 55,000 Newton is making a correctly banked 4G, that is the load factor, turn at an altitude where that sigma value they have given to us, it is nothing but 0.8. Sigma is nothing but density ratio. Okay, 0.8. The wing incidence, the wing incidence is 8 degree alpha minus 2 degree. Okay, dcl by d alpha, it is called slope, it is given 0.08 per degree, and 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 the wing area is and the wing area is 28 meter square, right? Find option 1 banking angle, option 2 radius of turn, option 3 time required to turn through 90 degree. This is the problem. Okay, and this is the problem number 3. First two problem we had solved in last class, you can check that lecture. Okay, so if you check all the given data, this 4G is nothing but load factor at any particular altitude. They have given density ratio, so you can calculate density for that particular altitude. Wing incidence they have given to us 8 degree, alpha they have given minus 2 degree. Okay, dcl by d alpha is slope, which is given 0.08 per degree. So the wing area is also given 28 meter square. So first we'll write the given data. Okay, what they have given to us, first we'll write this. It is weight, huh? Weight is 5000 Newton. Okay, then bank angle they have given, sorry, banked 4G. 4G is the load factor. Load factor is given how much? 4. N is the load factor, how much it is given? 4. Density ratio is given sigma. Sigma is nothing but rho upon rho naught, 0.8. So you can calculate what is the rho. No? It is 0.8 into rho naught. 0.8 into what is the rho naught? It is 1.2. Rho naught is the sea level density. So sea level density, it is pre-assumed. If it is given, okay. It is not given, it's also okay. Why? Because it is the sea level value, and that value you must know. So now you got here 0.96 kg per meter cube. This is the density at some at altitude, because density ratio they have given, it means it is aircraft is what flying at some altitude. Okay, fine. Then another turn at and this the wing incidence alpha they have given 8 degree. So I must write alpha they have given 8 degree. Okay, and 2 alpha value they have given. So you can say this is nothing but because this value is what higher alpha, so you can consider alpha 2, and alpha 1 you can consider it is negative value. It's your choice, anything you can choose, no problem. So minus 2 degree. Okay, fine. This is the alpha 1, because both are the angle of incidence or angle of attack, you can say. And dcl by d alpha also they have given to us how much? This is called slope. dcl by d alpha, it is given 0.08. Right. So what is the slope? dcl by d alpha. Okay, very importantly, when, because if this is the, if this is the cl versus alpha plot, so for the cambered airfoil, and obviously most of time it is cambered airfoil, if it is given it's okay, it is not given also, because alpha they have given negative value, so you can assume that it is the cambered airfoil. Okay, so this is the, you can say this is the alpha stall. Any two value they have given to us, obviously this value will be negative, this side it is negative, so here it is positive, you can consider alpha 2. That's the reason I said you can take this positive alpha 2, and this is alpha 1, because you are counting from this side 1 2. So alpha 1 they have given to us how much? Minus, I think, 2 degree. Check, alpha 1 is minus 2 degree, and what is the alpha 2? It is positive value, hence it is 8 degree. So if you check this value, okay, that value of alpha 1 and alpha 2, so if you check this plot, so this plot is nothing but cl versus alpha. Okay, cl versus alpha. Fine. So if you write this slope, which is nothing but dcl by d alpha, that also you can write cl2 minus cl1 divided by alpha 2 minus alpha 1. Yes or no? That you can write. Okay, fine. Why I am writing this? Because with the help of this slope and angle, we have to calculate the value of lift coefficient CL. Why lift coefficient will be required? Because To calculate radius of turn, all the formula if you write, what is the banking angle? It is phi. What is the phi? Simply you have to say phi is nothing but sec inverse some value, because sec inverse of n you can say, no? Why? Because what is the n? N is nothing but sec phi, which is nothing but load factor. All right. So banking angle you can calculate in this way. What is the r? R is nothing but radius of turn. And what is the formula for r? You know that formula. It is nothing but b square upon g tan phi. Okay, right? Or if you get the velocity, you can write in terms of, this is the velocity during turning or turning velocity. So that this v also you can write in terms of steady level speed, because what is the level speed? This v you can write n into v naught square divided by g tan phi. Okay, all right. And what is the time required to turn? That formula you should know, that time required to turn is nothing but, it is what? Psi r by v. Yes or no? And if you write that v in terms of v naught, so it will be psi r upon v naught. And that r value you have to keep here, then you will get time. So for all the, if you check calculation for the radius of turn and time required to turn, if you check it, then here you may get velocity term. And to get velocity, only one formula you have, that is nothing but steady state level condition, L is equal to W. And L will be what? Half rho v square SCL. From there you can calculate velocity. Yes or no? So for that you should know the formula of, check, I'm saying this part only. If you check steady state level, steady and level flow, what is that? It is L naught is equal to W, and it is nothing but half rho v naught square S into CL. So if you want velocity, because in radius of turn, if you check the formula, radius of turn formula, everywhere you will get velocity and time required to turn. Here also velocity term you may get. So you need velocity. What will be the velocity? Velocity will be what? 2W divided by rho S into CL. So how to get this CL? For that reason only, I'm just, because they have given the slope and all, so I'm using this formula. Hope you understood this. For that reason only, this part will be like the slope they have given to us. Okay. Now it is very clear. If you check for the for the negative angle of attack means alpha 1, what is the CL value? CL value will be what? CL1. And for alpha 2 positive value, CL value will be CL2. Yes or no? And here if you check in this graph, okay, where alpha 1 is given, so at that particular point, what will be the CL? CL1, it will be 0. Check this. This is what? X-axis. At x-axis, what is the y? Y will be 0. And what is the y? Y is CL. It means CL1 will be 0. But at alpha 2, this is the alpha 2. Here you may get some CL value. This will be the CL2. If you check alpha 2. Yes or no? So now this formula you can write Cl2, because only one Cl you have, so you can write Cl minus Cl1 will be 0. Hope you understood why it is 0. In the graph I have explained here, alpha 1 is the angle of attack, negative angle of attack, and this value is what? Exactly on the axis. And if you check the graph, so at alpha 1 where that value become negative, lift coefficient becomes 0. So CL respective value, I mean alpha 1 relate to CL1, so CL1 will be 0. And alpha 2 is nothing but how much it is? It is 8 degree minus minus plus because it is minus 2 degrees. So hope you understood. What is the A now? A is the slope dCl by d alpha. It is given how much? How much it is given? It is given slope 0.08 per degree. 0.08 is equal to this dCl you got Cl divided by what you got in denominator 8 plus 2. It means 10. So Cl will be what? 0.08 per degree into 10 degree if you multiply. So per degree, and this is nothing but 10 degrees. So degree cancel out. Yes or no? What you got? 0.08 into 10 means 0.8. This is the Cl, and Cl is the lift coefficient. Obviously for the lift coefficient there is no unit. Hope you understood. What is the velocity? Steady level velocity check. You have written the formula here 2W. Yes or no? Divide by rho s into. Now you can write the value 2W. What is the W weight? Weight they have given 55,000. Huh? 55,000 Newton they have given to us. We can keep here. What is the rho density at that particular altitude? You have calculated how much? You have calculated 0.976. It is nothing but 0.976. Area you have written somewhere where area is nothing but here. See, this is the 28 meter. You can keep this value into CL. You have calculated 0.8. If you solve this, check 2 into 55,000 divided by 0.976 divide by 28 divide by 0.8. Take root of it, you will get 709. Sorry, 70.9. Right. This is the velocity, but remember this is the V naught. V naught is the steady state level velocity, no? Or steady level flight. Steady and level flight. So V naught you got. Why you have written steady state level? Because only in case of the steady and level flight only L naught is equal to W. Okay, that I had explained last class, so no need to give explanation again for this L naught and L. There should not be any confusion. What is L naught? What is L? What is D naught? What is D? What is P naught? What is P? What is B naught? What is B? All the naught quantity are the steady level flight values. Okay, and without naught values like L, T, D, V, P, all the values are during turning. Okay, fine. So velocity we got. Now we'll write the radius of turn, and this radius of turn formula R is equal to n v naught square g tan phi. Yes or no? So we'll proceed this. What is load factor? First we need to calculate. Load factor is what? N. N is nothing but 6 pi, and n is given 4. So load factor is what? 4. Check. 4g they have given to us. See, this is the load factor. Fine. Number 2. Okay, if you want to calculate, suppose phi, so that phi you can write in terms of, phi you can calculate. You take phi as a inverse of sec inverse of 4, and then phi value you will get, and then you can write in formula tan phi and all. Otherwise you can write the formula R in terms of load factor only. What is the formula of R? R is nothing but radius of turn. It is nothing but V square upon G tan phi. What is V square? It is nothing but N V naught square. What is G? Tan phi is nothing but root of N square 1 minus 1. Yes or no? N is nothing but 4. Just now velocity you have calculated 70.93. Okay. G 9.8. If you calculate this value, what you will get? 70.93. So this value will be what I am getting. It should be square. Now it is 70.9. I'm getting it's a 530.21. 530.21. This is the radius of turn. So R. R is nothing but in meter. This is the radius of turn. What is the third number? It is rate of turn, time required to turn through 90 degrees. So 90-degree means what? Psi they have given to us, turning angle. Okay. So time required to turn, time required to turn. What will be time required to turn? P is equal to psi r divided by V. What you will get? It is nothing but psi, because psi they have given 90 degree. So that 90 degree you can convert into radian. So 90 into pi by 180. It is nothing but pi by 2 radian. So you need to write. And one more thing, this is the velocity v, you convert into steady level velocity. So it is n root of n into v naught. Psi is nothing but pi by 2 into radius is 530.21 divided by root of n means root of 4 into v naught is nothing but 70.9. We'll solve this. So pi into 530.21 divided by 2 divided by 2 divided by 70.93. I'm getting here 5.85 second. So this is the answer for the problem. Actually, that it was like aircraft was like just say this is the aircraft. Okay, fine. This aircraft is what can say it is turn exactly 90 degrees. Okay, so here it is exactly 90 degrees. So you can say this angle is nothing but psi 90 degrees. Hope you understood. So for this you have calculated, this is the condition for the problem. So what time it has taken to turn exactly 90 degree? It has taken from this condition to this 90 degree. Turn that time it has taken 5.87 second. Basically for the turning from straight to 90-degree turn it has taken 5.87 second. It's a very small time. Fine. So hope you understood this. This problem was like a little bit changed. I mean that slope and angle of attack was given. So I have explained so that the problem will be asked like this, so you can answer for it. Again, I will mention like here further this problem. Three values: banking angle, radius of turn, and time required to turn we have calculated. But in examination, the problem will be like very small. I mean one or two value will be asked, not more than one or two value, right? Maximum one or two value will be asked. Like we'll solve one more problem also, gate problem, so you will understand like how that problem they are asking to us. Okay, like very simple only, so you can understand like okay how that question will be asking in examination. So we'll solve this. This is the gate problem. Previous year question paper you have to start because now most of the part of the performance I have finished. Turning is going on. After turning, yes, pull up and pull down means vertical turning will be there. Anyway, so we'll write the problem. This is the gate problem. This is the gate 2011 for 2 marks. Okay. Now check. What is the problem? They have given an aircraft is performing a coordinated turn. Okay, maneuver at a bank angle of 30 degree and forward speed of 100 meter per second. Okay, assume g is equal to 9.81 meter per second square. The load factor and turn radius respectively. Okay, option is 2 by root 3 and 1.76 kilometer. Option B. What is the option B? Root 3 and 17.6 kilometer. Option C. 2 and 0.18 kilometer. Option D. 2 by root 3 and 17.6 kilometer. This is the problem, right? So this problem was asked in GATE 2011. It was for 2 marks. Okay. Simple. We'll write the given data again. Given data. What they have given to us? Coordinated turn means it is the horizontal turning. Maneuver bank angle they have given to us. Bank angle. Bank angle is denoted by phi. It is given how much? 30 degree. 30 degree. All right. And forward speed, it is given how much? It is 100. Forward speed, they have given forward speed. It is given how much? It is given 100 meter per second. 100 meter per second. Okay. 100 meter per second. Now G they have given to us. If they are giving, it's okay. If they are not giving, also fine, because it is pre-assumed value sea level. No? Now load factor and radius of turn we have. This is the great question. So for the forward speed, you may get confused, like, okay, this is the steady state level or turning speed. So that time I will suggest you don't get confused. Why? Because if they have used only term like forward speed, so it is, and banking angle is also here, it is given, so it is like indication whatever the speed is given, it is the turning speed. Understood? It is the speed during turning. Forward speed, it is speed. If it is steady state level, then in statement only they will mention. Okay, in statement only they will mention to you, so don't bother about it. Fine. Now what we have to calculate first? Load factor. So solution, what is the load factor for the turning? It is n, and it is nothing but sec phi. So sec phi is nothing but 30 degree. Okay, check the answer. It is 2 by 3 root 3. This type of value they have given to you. So what you will do, what is the sec phi value? Sec phi is nothing but reciprocal of cos phi, means cos 30. Okay, so n is equal to 1 upon cos 30. You can write, yes or no? You can write cos 30. Fine. And it is very simple to remember what is the sine value, what is the cos value. Yes or no? Cos 20, cos 30, cos 45. All right, this value you know, no? Cos 45, cos 60, sine 30, sine 45, sine 60, tan 30, tan 45, tan 60. All the value you have remembered already in 9th standard mathematics only. So there should not be any confusion. That's the reason I have just sec phi I have written as a cos phi. Cos 30 is nothing but, you know, it is root 3 by 2. So it is nothing but 2 by root 3. So what is load factor? It is 2 by root 3. Hope you understood. Next value, what you have to calculate? You have to calculate turn radius. Second, turn radius. What is the turn radius? R. Huh? V square G tan phi. See that forward speed directly they have given to us how much? It is 100 meter per second. So you write it. In fact, G value also they have given 9.81, and tan phi is nothing but 30 degree. Tan phi is what? 30 degree. Okay, put in calculator directly, you will get your answer. What is this? 100 square divided by 9.81 divided by tan 30, right? So it is 1765.59 meter, or 1.6759 kilometers. This is what? Turn radius. Turn radius, this is turn radius, and load factor I had calculated how much? 2 by root 3. Check both value. R is 1.76. Where it is? C, option 1. Yes or no? So such type question they have asked, and nowadays also whatever the question they are asking, it's very simple. Very, very simple. So I will suggest you to just be focused. That mean whatever I am teaching here, whatever the formula I'm deriving here, whatever the formula number of formula I'm giving and I'm saying this is important, you just remember the formula, you do that. That is more than enough. Nothing to worry. Okay, fine. Hope you understood this. Fine.